Differentiation, the derivative of a function. As we have seen in the previous video, the derivative of a function at a given point gives us the slope of the tangent line to the function at that point. From now, we change our point of view and we are interested in finding a general formula that gives the value of the slope of a tangent line for any x value. Thanks in advance for watching this video. If you like this video, don't forget to like and subscribe to the channel and activate the bell. It's very important for the continuity of this channel. The slope of the tangent line at x equals a is the derivative of function f of x at x equals to a. But now we are interested in finding a general formula that gives the value of the slope of a tangent line for any x value. In other words, we are interested in finding the slope of the tangent line at the variable point x f of x. We can do that by replacing a with x. This gives us the following formula for finding the derivative of f at any number x. So we can regard f prime x as a new function. This new function allows us to determine the slope of the tangent line for any x value. We can summarize our discussion as follows. Derivative function. For a function y equals to f of x, its derivative function f prime x is the function defined by whenever the limit exists. The domain of f prime of x is. Let's see how it works. To solve item A, we apply the definition of derivative function. The difficulty is in realizing that we need to rationalize the numerator. Carrying out the multiplication, we have. To solve item B, we replace x with 4. The derivative function is also known as the derived function or derivative function of f of x, or simply the derivative of f. Besides the prime notation, there are several other ways to express the derivative of a function. The most common ones are: this notation is read as f prime of x. This notation is read as d dx of f of x. This notation is read as dy dx. When we wish to evaluate a derivative at a number, we replace x with a when using prime notation, or one can also use the notation with a vertical bar. Pay attention. This notation is read as the derivative of f at x equals to a. This notation is read as the derivative of y with respect to x evaluated at x equals to a. During your calculus course, you will often hear the word differentiation. Differentiation means the process of finding the derivative of a function. Let's see another example. dy dx means the derivative of f of x. So we apply the definition of derivative of a function f of x above. let's evaluate the limit. Item B means dy dx at x equals to 3. So we replace x with 3. So far, we find the derivatives of functions by using the first principles. But as you have seen, this process is lengthy and for certain functions is cumbersome. We will now develop rules for finding derivatives without having to use the definition directly. These differentiation rules enable us to calculate the derivatives of more complicated functions. We begin with the two basic rules. Let's start with the simplest of all functions, the function. For the constant function y equals k, the derivative of this function is 0. This rule states that since a constant function is a horizontal line, its slope is 0. This rule can be proved using the first principles. A formal proof from the definition of a derivative is given as follows. There are two terms in the numerator, and they both are equal, so the subtraction of them is equal to 0. Let's see how it works. If f of x equals 2, find the derivative of function. The derivative of constant function is 0. If y equals minus 8, find f prime of x. The derivative of this function is 0 as well. We will now see how to find the derivative function of power function. Derivative of the power function. For the power function y equals x raised to the power of n, the derivative is. This rule states that the derivative with respect to x of x raised to the power of n, where n is a positive integer, is n times x raised to the power of n minus 1. A formal proof from the definition of a derivative is given as follows. We apply the definition of derivative, and we expand the numerator using the binomial theorem. Pay attention. After simplifying and factoring the numerator, we have every term has h as a factor except the first, so we obtain Let's see how it works. Differentiate with respect to x each of the following functions. To find the derivative of a power function, bring the exponent to the front of the variable as a coefficient and reduce the exponent by 1. Write 5 as the coefficient, then subtract 1 from the 5. The power rule provides a remarkably quick and easy way to calculate the derivative, because it can be extended to negative integer powers and rational powers. Although we have proved the power rule only for the case where n is a positive integer, it is valid for all real numbers n. We first need to rewrite the functions in the form of the power functions so that we can use the power rule. Pay attention.